Okay, now something that kind of looks like a law of addition, or a law of exponents really isn't. Let's try a plus b squared. Okay? What's that equal to? Probably want to say a squared plus b squared. I mean, that's what people want to write down. Okay? Maybe you don't, and hopefully you don't. But I don't know. I mean, had really strong algebra, and I was in a calculus class, still having to remind myself not to do it. You know, you get in a hurry. It's real easy to write it down wrong. I think I only made that mistake once on anything I handed in. And it was so embarrassing. Because I was supposed to be really good at it. And I was. It's just careless. Okay? So it's easy to write it down. Easy to do it. Almost everybody has done it wrong one time or another. Okay? So this is not a squared plus b squared, no matter how okay? Proof. Four plus 3 squared is not 4 squared plus 3 squared. What's 4 plus 3 squared?
7 squared.
Again?
7 squared.
Which is?
49.
Yeah. Got that? Okay. So this is 7 squared. Okay. What's 4 squared? 3 squared? Well, obviously that's okay. So that should convince you that you can't distribute a square through a sum. Okay? Exponents do not distribute over addition. Okay? Now, that's true. Okay? Multiplication does distribute over addition. Okay? And you're used to distributing multiplication over addition. And you're used to looking at it and seeing that that happens. So it's real easy to look at this and think it acts the same way, right? So you got to be careful. Because this is one of the number one things that people screw up. There are about 3 or 4 number one things that people screw up. I'm not sure which one's really number one. Okay? And it really causes problems. I mean, it causes you to get things wrong, but it causes you to misconceive things. Okay? So what is a plus b squared equal to? Well, the distributive law tells you. Now, it doesn't tell us this. That's just what squaring means, right? But then a plus b times a plus b is what? Well, it's a plus b times a added to a plus b times b, right? That's the way numbers work. A plus b is just some number, right? Doesn't matter that this is the same number, okay? Whatever's here is going to equal this times this plus this times this, okay? So the meaning of the square tells you that a plus b squared is this, right? Then the distributive law tells you this. That's really the distributive law of multiplication over addition. There is no distributive law of exponentiation over addition, okay? But exponentiation does distribute over multiplication, okay? But when I say the distributive law, I mean the distributive law of multiplication over addition, okay? And then by the same distributive law over addition, this is a times a plus b times a, right? And then this is a times b plus b times b, okay? And that's by the distributive law, okay? I don't have room to write out every step, but I can write out the last result and wave my hands over the rest. A times a is a squared, right? B times b is b squared, okay? What's b times a plus a times b? Well, how does b times a compare with a times b? How does 2 times 3 compare with 3 times 2? They're the same. Commutative law says it doesn't matter in what order we multiply things, and the commutative law is there just because we know this. We know what it means to multiply 2 by 3, okay? If I have 3 things and then I have 3 things again, I've got 2 3s, which is 6. Or if I've got 2 things and another 2 things and another 2 things, I've still got 6 things, right? So 2 times 3 and 3 times 2 are identical. And we know the same is true for any pair of numbers, okay? Because that's the way the world is. Not something that was handed down on a stone tablet. If we had some other opinion, we'd be messed up, okay? And we wouldn't be sitting here, we'd be chiseling pictures in caves. And probably bad pictures, because we don't know the commutative law, okay? Can't draw good pictures without the commutative law, think about it. Nah. Okay, so what we got, b times a and a times b are the same thing, so we got 2 a times b's, right? This is 2ab. Now, when you're learning to factor, you kind of memorize that a plus b squared is a squared plus 2ab plus b squared. If you memorize that without understanding why it's true, then the next time you see it, after you're done circling the numbers on an SOL or test or whatever, a month after that, you won't remember it anymore because you don't understand it. That's not, it's not that easy to understand. It takes a little work. Okay? But you got to learn at this point, because this course is a transition between the stuff you've had before and the stuff you need to really use this. Okay? You need to start understanding reasons. And you also need to get all the rules really straight. Not easy to do. That's why I say it takes time in this course. Okay, so again, another big deal is the distributive law. Okay? And of course, another one that isn't true this one's really easy to do. Really easy, even for people that know. Get careless, you can write that down very easily. Okay? And it's not hard to write that down either. It's tempting. Okay? Even after I'd learned calculus, it was still tempting. I was just paranoid enough not to do it anymore. Okay? You get a little paranoid, you can't get through life without being a little, well, yeah, you probably can. Okay? Make sense? So there's some pitfalls that I want to warn you against, and also give you an idea of the fact that the laws of algebra aren't just rules that you memorize. There's a reason for them. Yeah, some of them you just about got to just memorize, you know, they get weird enough. Okay, but your basic laws of exponents all make sense. Okay, at least for integers. So let's, we got close to 10 minutes left, so let's make use of some of these laws of exponents. Now I'm probably going to give you an assignment that I'll just copy out of the online textbook for this course, which is an intermediate algebra textbook. Okay? Just give you, a bunch of problems that involve laws of exponents. See what you can do with them. Okay, don't expect you to be experts when you come in Tuesday, but if you are, I'll be happy. And so will you. Okay? And maybe you will be. So let's think of what's a squared b to the 7th cubed? Okay, now we need to break it down, okay? I'll tell you what it is because it's going to look familiar to you. Then I'll tell you why, because there's another law of exponents involved that we'll probably talk about more in class too. Okay? Maybe not, because we've got other things we need to do also. Okay, a squared b to the 7th cubed is a squared cubed times b to the 7th cubed. Okay? Exponentiation distributes over multiplication. Okay? A times b to the c equals a to the c multiplied by b to the c. It's another law of exponents. Okay? and one that's actually pretty easy to understand. So we might end up talking about that in class. We've got limited time in class, so I got to kind of prioritize. I'm going to actually glance at what people hand in and see what I think we need to talk. Actually, I'll be able to take more of than a glance because I'll have you work these assessments. Okay? So I'll get a pretty good idea. Okay. Makes sense? You understand that this is an application of this? Well, maybe I'd better put a multiplication sign in here. Okay? So when something is multiplied by something else and then raised to a power, you take the first thing and raise it to that power, you take the next thing and raise it to that power. Well, here you have two things that are multiplied, and just because one of them happens to be a power of the same letter I used over here doesn't matter. You still have two things that are being multiplied, so I could put it like this, right? To be formal about it. So here's something multiplied by something else, and all that is raised to the third power. It equals this, right? Okay? And of course then, a squared cubed is a to the 6th. B to the 7th cubed is b to the 21st power, right? Now to see why this works, what if it was just a squared times b cubed squared, just so I don't have to write down too many terms. Okay, what's that mean? That means a squared b cubed times a squared b cubed, right? You agree? Well, that's the same. If we could write that down again, I'm being a little bit careless and writing down the wrong symbol. We don't really need parentheses in a series of multiplications. There's a reason for that. Associative and commutative laws, and you keep regrouping and you can change the order of anything. But basically, any series of multiplications can be grouped any way you want them. And as long as you just have a series of multiplications, it doesn't matter how you group them. It comes out like this. Also, it doesn't matter what order they're in, does it? It doesn't matter what order you multiply four numbers in. So I could write this as a squared times a squared times b cubed times b cubed. Right? So a squared times a squared, I didn't even want to write it that way. I mean, I could have, you can overdo the number of steps because I think it's going to be pretty obvious. A squared times a squared is a squared squared, right? And b cubed times b cubed is b cubed squared, right? Well, that's just what the rule says. Okay? It says that a squared b cubed is a squared squared, a to the c, right? There it is. B cubed squared, b cubed squared, right? Okay? Try this one. Actually, no, we're out of time. And you guys are going to go brain dead on me. Don't want that to happen. I want you to fresh yourself up a little bit for class. Okay? Now, if you got questions, I'll answer them. If you want to just let your brain rest for a while, I'll wash a few boards. But I'm just washing boards. You talk to me while I'm washing boards. Okay? But if you want to go run around the building a dozen times, go ahead. Want to go get something in the snack bar? Want to just get out and beat your head against a wall for a while? That's fine. Don't hurt yourself. You guys look pretty tough. I think the wall would be the one that suffers. Not saying that you're hard-headed. No way. Don't have any suspicions.